Hey guys, and welcome to part 1 of the cross product, also known as the vector product. Let's assume that we have two vectors, a and b, with components given by a1, a2, a3, and b1, b2, b3, respectively. When we're finding the cross product, there are two definitions. The first definition is just memorizing the formula. So if we want a cross b, we have to do a2 times b3 minus a3 times b2. That gives us the first component. Then we have to do a3b1 minus a1b3. That's the second component. And then we have to do a1b2 minus a2b1. That gives us the third component there. That is not my preferred method of doing this. I prefer to use the matrix method. So the second definition is a cross b is the determinant of this matrix over here. When I'm using these lines for this video, that does not mean modulus. That means determinant. And what we need to do is we need to find the determinant of this matrix, subtract the determinant of this matrix, and then we're going to add the determinant of this matrix with the I, j, k components in that form. The easiest way to do this is just to practice it, and it gets very easy over time. Now, obviously, we're going to be talking a little bit about determinants of 2x2 matrices for this lesson. And just remember that when I'm using these lines in this lesson, I'm talking about the determinant. I'm not talking about the modulus of that. What you might also realize is that the cross product or the vector product gives us a vector as a result that is different from the dot product, which gave us a scalar as a result. All right, so what we're going to do is if I got A and B, what we do is we set it up the matrix as I, J, K notation. We put the A components in the second row and the B components in the third row. So I'm just going to show you how the second definition compares to the first definition. I'll teach you how to get this result quite easily in the next slide. But for now, I just want to prove that the first definition and the second definition will give the same result. So obviously to do this, we need to understand what the determinant of a 2x2 matrix is. And we know that if we have a matrix A, B, C, D, the determinant of that matrix is going to be AD subtract BC. Alright, so when we're working out the first component, we have to do A2 times B3. Take away A3 times B2. That'll give us our first component. Then we'll take away A1 times B3. Take away A3 times B1. That'll give us our second component. And then we'll do A1 times B2. Take away A2 times B1. What does that look like? It looks like this. We're going to do A2, B3, take away A3, B2. Then we're going to do take away A1, B3, A3, B1. And then we have A1, B2, take away A2, B1 over there. And don't forget to put your I, J, and K components, where I is the X direction, J is the Y direction, and K is the Z direction. Let's look at how that compares to the first definition now. You can see we have A2, B3, take away A3, B2 in the I direction. So that's the first component. Now, can you see how the A3, B1, take away A1, B3 is different to this one over here? That's because we still need to put the negative into the bracket. So when you put the negative into the bracket, you'll end up with A3, B1, take away A1, B3. And the third component is just A1, B2, take away A2, B1. I know that this looks very complicated, but I'm going to show you a really quick shortcut on how to remember to do this. Let's just go through an example now. So we want to find the cross product between A and B. So the first thing I'm going to do is I'm going to set up this matrix here. So it's always going to be I, J, and K at the top. And we're always going to have the components of A in the second row and the components of B in the third row. This is how we set it up. Then what we're going to do is we don't need to remember all of this stuff over here. All right, I'll just put that in there as a reminder of how to do it. But just remember that it's I minus J plus K with whatever the determinant is in those positions over there. So how do we determine this A2, A3, B2, B3? Well, we're using the I column. We cross out the I column and look at the numbers there. That's A2, A3, B2, B3. That's how we get that 2, 3, negative 1, 2. Then to get the J column, all we do is we just move that column across, like so. And you can see the numbers there. Look, A1, A3, B1, B3. Don't have to write this step out every time. So all we want is we're going to do the takeaway. That's very important. Takeaway 1, 3, 3, 2. 1, 3, 3, 2. Then for the K component, it's a plus. So we're going to go plus. And when we move that across, we're going to cover the K component. And we have 1, 2, 3, negative 1. 1, 2, 3, negative 1. So as long as you can set up this matrix over here, and you remember that it's take in the middle, you're fine, because then you just cover up the I column, cover up the J column, cover up the K column, and that'll tell you what the number should be. Then we need to remember what the determinant of a 2 by 2 matrix is, AD minus BC. So in this case here, we're going to do 2 times 2 minus 3 times negative 1. That gives me 4 plus 3. We're going to do AD take away BC, so 2 take away 9 goes into that one over there. And then minus 1 minus 6 goes into that one over there because it's AD take away BC. And don't forget that negative. And then we just need to clean it up. 4 plus 3 is 7. 2 take away 9 is minus 7 times a negative gives me a positive 7. And minus 1 minus 6 is minus 7. So the cross product between A and B is going to be 7i plus 7j minus 7k. You don't need to write all of this stuff out over here. This step here is important, but we don't need to do this step. All right, so what we're going to do now is we're just going to look at a few properties of the cross product. So we know that the cross product of the previous example was 7, 7, negative 7. And what I'm going to do now is I'm just going to do the dot product between each vector and the cross product between the two. So we're going to find the dot product between A and the cross product of A and B. Gives us this equation. And when you solve that, you should end up with 0. Now just remember, what happens when the dot product equals 0? What does that tell us about those two vectors? Likewise, if we find the dot product between B and the cross product of A and B, you'll also find that it equals 0. Interesting. Now, if the dot product equals 0, what does that mean about the two vectors? Remember, when the dot product equals 0, that means that the vectors are perpendicular. So the vector A cross B, the 7i plus 7j minus 7k, is perpendicular to A and B. So if this is my vector A, and this is my vector B, so what we'll end up with is a vector that is normal to both A and B, which looks kind of like that red line over there. So that's A cross B over there. Now, we don't know if A cross B is going up or if it's going down just yet. We'll talk about that in a later video. Now, imagine that A and B are on a plane. Okay? Any two vectors, you can put a plane between them. What you'll notice is that the A cross B is perpendicular to A, and the A cross B is also perpendicular to B. This is a very important result. The cross product between two vectors will always give you a vector that is perpendicular to each of those two vectors. So the cross product of two vectors will always give a vector perpendicular, orthogonal, normal, all mean the same thing, to both of the vectors. And we can see that results over there because the dot product of both of the vectors with the cross product equaled 0. All right, so let's look at another example now. Find the cross product between A and B if A is 1, 3, 4 and B is 2, 7, negative 5. Now what we do is we just set up the matrix. So we go to I, J, and K. We got the components of vector A and we've got the components of vector B. Then what we need to do is we need to cover up the first column. That's going to be our R column and it's positive. And we're going to find the determinant of these four numbers over here. So 3, 4, 7, negative 5. The next bit for the J, is that going to be a positive or a negative? Find out. We'll move that across. So the numbers that should go into the determinant for the J are going to be 1, 4, 2, negative 5. And it's a negative. Don't forget that it must be a negative in the J component there. And we'll do the same thing for the K component. So we'll move that across. And the numbers that we want in this matrix are going to be 1, 3, 2, and 7. And we'll put the K component on the end there. Now we need to define the determinants of each of these. So to do that, we use the formula up at the top here. So AD minus BC. All right, so what does that give us? Well, we're going to have 3 times negative 5, which is negative 15. Take away 4 times 7 is 28. Take away, because that's the same, 1 times negative 5 is negative 5. 4 times 2 is 8. We'll take that 8 away. Plus 1 times 7 is 7. Take away 3 times 2 is 6. And when you simplify all of that, you'll end up with negative 43 plus 13j plus 1k. Let's just have a look at how we can do that in our class pads. What we'll do is we'll go to action, vector, cross product, and then we'll type in the two vectors. So the first vector was 1, 3, and 4, and the second vector was 2, 7, and negative 5. And when you find the cross product between those two, you end up with negative 43, 13, and 1. Now just quickly, what I'm going to do is I'm going to do the cross product the other way. So we're going to do B cross A and see if the order is important. So we'll get rid of that vector over there, and we're going to do B on the cross product between B and A. And what you'll notice is that we get the exact same vector, except it's going in the opposite direction. So A cross B is the same as minus B cross A. Now just quickly, let's see what the dot product is between those two vectors, because the dot product between the A cross B and the original vectors should be 0. So that's A cross B dot A is 0. And likewise, we can do the same thing with the dot product and B. So that should also give us a result of 0 if we've done it correctly, because the cross product is normal to both of the original vectors, which we can see over here. Alright, so what I want you guys to do now is I want you to have a go at finding a vector normal to both A and B. So pause the video, have a go for yourself, and then press play when you want to get the answer. Alright, so let's go through the answer quickly. I want to find the so to determine a vector normal to both of these vectors, they're asking us to find the cross product, because the cross product will give us a vector normal to both of the vectors inside the cross product. So what I'm going to do is A cross B, we'll set it up. It's going to be I, J, and K, and then we're going to write in the components, so negative 2, 3, 2, 1, negative 4, negative 5. And then what we're going to do is we're going to ignore the first column, and we're going to write in those numbers, so 3, 2, negative 4, negative 5. And those will go in the I direction, plus, no, take away. We're going to cover up the J column, and we end up with negative 2, 2, 1, negative 5. Those are in the J direction, plus, cover up the last column, and we have negative 2, 3, negative 2, 3, 1, and negative 4, and those go in the K direction. Then we need to define the determinants of each of these. So 3 times negative 5 is negative 15. Take away 2 times negative 4 is going to be a positive 8. The negative and a negative makes it a positive, and that's in the I direction. Take away negative 2 times negative 5 is 10. Take away 2, that's in the J direction, plus 8. Take away 3 in the K direction. Now we just need to simplify that quickly. Minus 15 plus 8 is minus 7 in the I direction. 10 take away 2 is 8, so it's going to be negative 8 in the J direction, because I've got that negative at the front there. And then 8 take away 3 is 5, so it's going to be plus 5 in the K direction. How do we check that quickly in our class pads? Get your class pad out, go action, vector, cross product, and then we'll type in both of those vectors. So vector A is negative 2, 3, and 2, and vector B was 1, negative 4, negative 5. When you find the cross product, that gives us minus 7, minus 8, and 5. So I did it right. That's the end of part A for the cross product. In part B, we're going to be looking at an important result, so make sure you check that video out as well.